Alright, here are solutions to perfect problem 6 from Math 65. We're given three polynomials here and asked to factor them, and then check our answers by multiplying back together. Alright, so this first one we're going to factor by grouping, because it's got four terms. So the way we'll do that is look at the first two terms and look for their greatest common factor. In this case it's 2x squared. And if you pull out a 2x squared, you'd be left with x minus 5, just x here and a negative 5 here. And then to be left with x minus 5 over here, we'll have to pull out a negative 3. And so now what we can do is pull out an x minus 5 from each of these two terms. And that'll leave us with 2x squared minus 3. And so what we've now done is managed to factor this thing down to here. You can check our answer by multiplying those factors back together. If we did 2x squared minus 3 times x minus 5, you can either FOIL or use this little box method. If you multiply x times 2x squared, you get 2x cubed. X times negative 3, you get negative 3x. Negative 5 times 2x squared, you get negative 10x squared. Negative 5 times 3, you get positive 15. And if you add those all up, what you get is exactly what you should get. 2x squared minus 10x, 2x cubed minus 10x squared minus 3x plus 15. Alright, let's do the second one. Factor x squared plus 2x minus 8. The way we can do that is we need two numbers that multiply to negative 8 to whatever our constant term is and add to positive 2. And the way I figure that out is I write all the factors of 8, all the positive integer factors of 8. 1 times 8 equals 8, 2 times 4 equals 8, and that's all of them. If I want to multiply to negative 8, I need one of these two to be negative or one of these two to be negative. And to add to positive 2, I'd need to use these two, with the 2 being the negative one. In other words, the two numbers are negative 2 and positive 4. And so I can factor this as x minus 2 and x plus 4. And then I could check my answer by multiplying x minus 2 times x plus 4. And if I did that with the box method, I'd get x squared minus 2x plus 4x. Try to separate those a little bit. And negative 2 times 4 is negative 8. So I'd get x squared, let's see, 4x minus 2x, it leaves me with positive 2x. And then minus 8, which sure enough is what I got up here. I could do that one more time. I could do 6x squared minus 30x plus 36. I could try to factor this thing. Might look harder because the leading coefficient's not a 1. The good news is these three terms have a greatest common factor of 6. And if you pull out that 6, what you're left with inside the parentheses is a trinomial with leading coefficient of 1, so we can factor it. To factor it, we need two numbers that, see, they'd have to multiply to positive 6 and add to negative 5. And I could figure that out. Let's see, the numbers that multiply to 6 are 1 times 6 or 2 times 3. To make them multiply to positive 6, I need them both to be positive or both to be negative. And if they're both negative, I can use the bottom two to get them to add to negative 5. I can say negative 2 and negative 3 will multiply to positive 6 and add to negative 5. So I can factor this as 6 times x minus 2 times x minus 3. And then I can then check my answer by figuring out that 6 times x minus 2 is equal to 6x minus 12. And 6x minus 12, well, 6x minus 12 times x minus 3. If I multiply all three of them together, here's the first two and here's the third one. use the box method. X times 6x is 6x squared. Negative 12 times x is negative 12x. 6x times negative 3 is negative 18x. And negative 3 times negative 12 is positive 36. And if you collect like terms, what you get is 6x squared minus 30x plus 36, which sure enough is exactly what I was supposed to get. Whew, so I guess I did everything right, and I guess that's the end of this perfect problem.